So my name is Ms. Ramirez, and in this segment, we're going to be learning about how temperature can change materials. So hopefully you remember from Mr. Monroe's segment that we use a thermometer to measure the temperature or the amount of heat energy that a material has. So when we talk about temperature, we're talking about the amount of heat energy. So what are some ways that we can add heat to materials to make them hotter? Also think about what are ways that we can remove heat to make them cooler or cold. So be thinking about different ways that you might use at home or at school to add or remove heat. I'm going to show you a few examples, and y'all are probably already familiar with some of these. If we wanted to add heat or make things hotter, you could use an oven or a stove, a microwave, maybe a campfire, or as Mrs. Fuller showed you guys, we can use the sun's energy to help us heat things up. Now, what if we wanted to do the opposite? What if we wanted to remove heat and make things cooler? Well, we could put things in a cold refrigerator or freezer. If we wanted to make our drink cooler, we could add ice. But also our air temperature changes during the season. So during the winter time, we have a cooler air temperature. We might see snow or ice, while during the summertime, we have a hotter air temperature. So let's look at an example of how temperature changes materials. And we're gonna first look at our popsicles. So y'all are probably familiar with popsicles. These are kind of like the ones I grew up eating. Make some observations. What do you see? What do you guys notice? Compare these two. So how are they different? And what do you think happened to them to make them different? So let's start with this one. Because I'm able to actually touch them, I can feel that this one is squishy. So I can squish it and you can see it's a liquid. So the liquid is moving. You can see it flowing through the plastic wrapper. It also feels warm to the touch. This one, on the other hand, is different. This one feels hard. I can't squeeze it. It is also really cold because I just took it out of the freezer. It's a solid, so it doesn't move freely throughout the little plastic container. So this one is a liquid and this one is a solid. So how I got a solid, I simply put this in the freezer. I removed heat energy. It got really cold and it froze and turned to a solid. Now, if I have this solid popsicle, what is something I could do to make it turn back into a liquid? Well, super easy. You can either leave it in your room and let it start to melt as it gets warmer, or if you wanted it to melt faster, you could stick it outside on a hot summer day, and then the sun's heat energy would start to melt the solid popsicle and you would get your liquid back again. So do you think all materials will behave the same way? So do you think all materials will melt when they get heated? Do you think all materials will turn into a solid when they get cold? So we're gonna look at an example of how other materials might change. So we're gonna be doing an experiment with a bouncy ball. We have heated up 3 balls. So one bouncy ball I left at room temperature. One bouncy ball I put on a hot plate. And a hot plate is kind of like a little mini stove top. I put water on a hot plate. I got it really hot and to boiling, and then I put my bouncy ball in that hot water. And then I have a cold bouncy ball that I stuck in the freezer overnight. So we're gonna test to see what happens to these different bouncy balls at different temperatures, and we're gonna see if it affects their bounce height. So before we do our experiment, make a prediction or a guess. What bouncy ball do you think will bounce the highest and why? Now, I'm going to show you a video of the experiment because I couldn't do it now because I have to have that bouncy ball super cold, and you have to do the experiment right after you take that bouncy ball out of the freezer. So I tried doing it live yesterday and the results did not come out like they were supposed to, because by the time it was my turn to present, my bouncy ball that was frozen had already gotten quite warm, almost to room temperature. So if you do this experiment at home with the help of an adult, just make sure that you do your bouncy ball that's frozen, make sure you drop it first. So I'm gonna go ahead and share my screen, and I'm gonna show you guys the video. Y'all are gonna practice being a good observant scientist. Y'all are gonna use your sense of sight and also sound. Notice some of the sounds the bouncy balls make as you guys observe the experiment. Today we're going to be doing an experimental investigation to see which ball will bounce the highest. We're going to compare a ball that was set at room temperature. We're going to compare a ball that's been placed in hot water and a ball that's been placed in the freezer. So let's look at some of our science equipment that we will be using. Here we have a hot plate. A hot plate is kind of like a little mini stove top. It is heating the water inside this beaker and also the ball, which is floating in the beaker. So a hot plate, the temperature right now in that water is about 90 degrees Celsius or 194 degrees Fahrenheit. So that's going to be our hot bounce ball. Then we have our cold bounce ball here in the middle. It was in the freezer. It was about -10 degrees Celsius or 14 degrees Fahrenheit in the freezer. I placed it in a beaker full of ice just to help it stay a little bit colder. And then we have our room temperature ball, which is about 22 degrees Celsius or 72 degrees Fahrenheit is about the temperature in my room. Now we're going to be using a data chart like this to record our data. We're only going to have time to do one test today, but ideally a scientist would conduct at least 3 or 4 tests to make sure their results are accurate. But we will be filling out our chart. And then we also have this height chart just to make it a little bit easier to see how high the balls actually bounced. And I just used the meter stick that you see above us to help us mark some lines. I used it in inches and in centimeters. We're going to test the cold ball first. That way it doesn't have time to warm up in my room. We're going to drop it at a height of 43 inches. So hopefully you saw that it went just above 20 inches, and I hope you heard that loud sound it made when it smacked the floor. So we're going to put our mark for 20 inches for the cold ball. Now we did our cold ball, and that was just above 20 inches for its height. So now we're going to do the room temperature ball, and we're going to drop it at the same height, about 43 inches. So you can see it went around 35 inches, so we'll go ahead and mark that. And the last ball that we're going to test is the ball that's been heated using the hot plate. So I'm going to use a spoon to take that out of the hot plate in the hot water, and then we'll drop it again at the same height. And it went just above the room temperature ball. So you can see that the ball that bounced the lowest was the cold ball. The room temperature ball and the hot ball actually bounced the highest. So we're going to discuss those results in just a little bit, but we're also going to take time to put our results into our little data chart as well. Okay, I'm going to stop sharing the screen and then we'll talk about our results. So hopefully you guys were able to see that the ball that did not bounce very high was actually the cold ball. And I conducted this test 4 times, and overall, the hot and room temperature balls had the highest bounce height, while the cold bouncy ball always had the lowest one. Hopefully you guys were able to notice the difference in sounds that the different bouncy balls were making. There was a big difference between the way the cold ball sounded when it hit the ground versus how the other 2 bouncy balls sounded. So the cold bouncy ball, when I took it out of the freezer, you could feel a difference in how it felt. It felt literally like rock hard. It was really hard and solid compared to the way these other 2 bouncy balls felt. So it was no surprise to me that it made that loud noise when it hit the ground. So why exactly was that cold ball not able to bounce? Well, it all has to do with particles. All matter is made out of small little particles. So what ends up happening is with temperature, the particles either slow down or they move really fast. So in the case of our cold bouncy ball, the particles that are inside the cold bouncy ball, when I put it in the freezer, those particles they froze. They got really slow moving, and there's not a lot of energy in it. So when I dropped it, it didn't have a lot of energy to bounce back up. Now, it also affected its elasticity, and that's this word here. Elasticity is just the ability of a material to go back to its original shape. And y'all are probably familiar with elasticity because you've probably seen a rubber band, or I put a band on my hair. So the rubber band, I can stretch it, but it always goes back to its original shape. It's the same thing with a bouncy ball. When you drop the bouncy ball, it gets slightly compressed when it hits the ground, but then it regains its shape and it uses that energy to go back up and bounce. So you want a bouncy ball that has good elasticity, otherwise it's not going to bounce. So if you compare it to a marble definitely feels different than a rubber bouncy ball. The marble feels much more solid, very hard, and it doesn't have very good elasticity. And then when you compare our cold bouncy ball particles to our room temperature bouncy ball and our hot bouncy ball, the particles that are within these bouncy balls, they were moving much faster, they had more energy, and they were able to bounce higher. So that's our bouncy ball experiment, and it just shows us that materials react differently to heating or cooling. So not everything's gonna melt just because it gets heated up. So the last thing I wanted to show you guys is just a little video. It's gonna be some ducks that are out here on our farm, and it's a challenge question. So I want you to be thinking about how does the heating of water and the cooling of water affect our farm animals? So I'm gonna share my screen again. I have a super quick video to show you guys. Again, be observing what you see. So hopefully you were able to hear those sounds from not only the ducks, but the chickens and roosters that were out there as well. I'm gonna stop sharing my screen and we're gonna finish our presentation off. So again, be thinking about what's gonna happen to that puddle of water during the wintertime when it gets cold, what's gonna happen to that puddle of water during the summertime when it gets super hot, and how is that going to affect our farm animals out here?